How's it going? And welcome to one of my first, not one of, to actually my first video on the Raspberry Pi. So what I have sitting here is a mess, just a big ol' mess. No, what it is actually I have a little frame from a tank kit that I got a while ago. Oh, that's coming off. Hooked up to a motor controller powered by the L298N chip. It's a pretty cool motor controller. I actually have two of them. Very cheap, and this one's been working pretty darn good so far, so I don't have any complaints about it. But I'm going to go over how all this works. So about this board, what it'll do is take an input voltage through these three pins and will send that voltage out these two, which is what would be linked to your motors, and that's what I have down here. I have these two pins linked to one of the motors under the, actually let me turn this over that way you can see the motors. I have these two linked to this motor, which is driving these three wheels, and they're not suction cups, they just look like that. But anyway, and this terminal is driving this motor. Now, real quick explaining what I'm using the motor controller for is that these four pins here are hooked up to the Raspberry Pi. These are what control the output, so when one of these pins are pulled, it will send an output through these. The four input pins hooked up to the GPIO pins on the Raspberry Pi. So when I get to the coding, you'll see how all this works. But basically what the coding does is it'll take a keyboard input. If I push W, for example, what'll happen is that one of the input, or actually two of the output pins, will be set to true, so it will put out 3 volts onto this, and then it will drive the two motors into here to the correct direction to push the whole frame forward. And here I have an external battery pack with 4 AAA batteries to supply 6-volt input voltage into the controller, so it would give that voltage out to the motors. So as you can see on the screen here, I have a VNC viewer pulled up, and what it's actually doing is showing what the Raspberry Pi's desktop would look like, but as you can see, the only thing plugged into my Raspberry Pi is the power and these few wires. So real quick, to show you how you can set up this viewer, is you would click the start button, what would be called a start button, whatever you want to call it, the button up here that has a picture of the Raspberry logo on it. Then come down to Preferences, Raspberry Pi Configuration, Interfaces, and then right here where it says VNC, you would click Enable, then hit OK, and reboot your Raspberry Pi. And then when it comes back up, you would see this appear in your taskbar. You'd click on that, and it would give you your IP address. Mine's going to be blurred out, but it also has a whole bunch of other ways just to make sure that you're connecting to the right Raspberry Pi. And then on your computer, your actual desktop or whatever you're using to connect to it, my desktop, my laptop, and my phone can connect to the Raspberry Pi using VNC Viewer. But you would download VNC Viewer. I'll have a link in the description so you can check that out. And it would pull this up, and you can type in the IP address of your Raspberry Pi, and you would log in with, don't want to close that, and you would log in with your Raspberry Pi's username, which you can figure out by going back to Preferences, Raspberry Pi Config, and the host name should come up as, or not the host name, the username would come up as Pi, and the password would be whatever you change it to, but the Raspberry Pi default password is Raspberry. I changed my password because leaving it default, people can hack into it. You don't want that, and so anyway, I changed it. But anywho, so that's how you can set up a VNC viewer. Just a quick rundown of that. Links and whatnot will be down in the description, but of course there's a whole bunch of other tutorials on how to do it and whatnot. So anyway, back to this mess of wires. So what I have hooked up here, and actually let me just go ahead and pull up the code whenever this wants to come up, and recent, boom. So here's my code to get, oh geez, I don't know if the camera will pick up that. So this be my code. Wow, oh my god, coding. I'll explain what's going on here. So to start out, importing the raspi.gpio as GPIO. That's importing the GPIO library so you can control your GPIO pins on your Raspberry Pi. And importing curses is it imports the curses libraries to read the keyboard, which I'm using a, I don't know if this would be called a micro or mini keyboard or what. It's a small wireless keyboard. It has touchpad on it, a bunch of buttons and whatnot. But anyway, this is what I'm using to control the GPIO pins. Then I have the GPIO.set warnings as false, because what happens when you run these codes, it doesn't necessarily well, it'll turn the pins off, but when you go to run it again, a warning will come up saying that channel is already in use. By channel, it's referring to the pins that are being used in the code, saying that they're already in use. But if you don't want to see those warnings, like me, I keep seeing the warnings even though everything's turned off. It's just to let you know that those are pins being used. You can turn the warnings off by just using this little line right here, GPIO.set warnings false. And the GPIO.set mode, GPIO.board, that is referring to the pin layout. So let me grab this little guy here. This is the pin layout, but notice how you have the individual pin numbers, like, let me get in a little closer so you can see, like 1, 2, 3, 4, 5, 6, and so on all the way down to 40 for the Pi 3. Those are the board identification that numbered. That's those numbers. When you type in GPIO.board, it refers to those numbers to identify the pins. Now another thing you can type in instead of, oh my god, now another thing you can type in instead of board, you can type in BCM, which then will look at these numbers like GPIO 17, 27, 22, and so on. Then moving on in the code, I have these few lines. Actually, let me separate these so we can just see it a little bit better. So these lines are, these 4 lines right here are setting what the pins are going to do. So GPIO.setup 11, GPIO.out means that pin will be set as output. So it would only give an output voltage. It won't take input voltage. If you put in GPIO.in, then it would be input, and that could be used for sensors like the obstacle avoidance sensor. When this senses something at a distance, which can be adjusted with this variable resistor, when it senses something, it's going to give out a voltage, and if you were to set a pin as input, it would take in that voltage, and then you can use that voltage to do whatever you want. So, moving on with the code, we have some curses stuff set up. What's going on here is this is initiating the screen, which you have to use your terminal this in order to use this code. Curses works on this terminal. I don't understand curses very clearly, but from other videos I've seen, which aren't a lot, this is what I get from it. And then no echo means when you hit a key, well, for instance in my code I only use the keyboard, so when you hit something on the keyboard, it will not echo what the key you pushed in the terminal. It'll just stay blank. And then going down to curses.c break, that is the delay in between pushing a key on the keyboard and the code doing something. So there's no big gap between the keyboard input and the coding output. And then screen.keypad is basically like initializing the keyboard. So then going down, in a try finally loop, I have a while loop. This is setting the character input that the terminal is going to catch. And for the first line, I have an if character is equal to coordinate, well, I'm just going to say coordinate Q, that just is referring to if the Q button is pushed, then it's going to break the code. It's going to quit everything and shut down curses, which is what all this stuff down here is. And I'll explain that when I get to it. Now down here, next thing I have is an else if or elif for short in here because you don't feel like typing else if. Anyway, so what's going on here is that when the character at coordinate W or the key W is pushed, it will set the pins 11 and 18 to true, 13 and 16 false, so it will drive the motors forward, get them to spin in the correct direction to get the frame to move forward. And then that's the same thing for the other ones. S to drive it backwards, it reverses the pins output. And then U, the thing with curses is that when you push a button, like if I were to push W, the way the code is set up is that it'll keep going forward even if I let go of W, so there has to be a button that will stop it, and that's what U is for. When you push U, the motors will stop completely. Then down here, elif character equals O, that spins it right, and then I spins it left. And then down here finally, when you push, or when I would push Q in the code, it would skip all of this stuff and come down here, which all this basically resets curses and exits out of it. And then the GPIO.cleanup, it sets all the pins back to a false output. So that's the code explained, and that's the link up I have going on down here. So I'm going to change a few wires real quick and then I'll show you Strawberry in action. So be right back. And done. Alright. So what I want to do real quick was just switch the wires to the colors on here, so if I unplug it or it becomes unplugged or anything, I'll know where the wires go back. So throw in the batteries. And you'll see on the motor controller that a light comes on to show that everything is powered up. So let's turn Strawberry back over. So I don't have any like really good way of doing this right now, which later on I'm working on building a frame, so I don't have to do this because it's not very clean, and it's not a very clean way of doing everything and whatnot. But anywho, all this would be put up on here, but because these are plastic wheels on a very smooth wooden desk, it wouldn't get very good grip with all that weight on top of it, even though this isn't a whole lot of weight, but you get the point. Just showing what's going on. So we'll run the code here. Everything looks good. So to run the code, you have to pull up the terminal and type in, quit doing that, and type in, not reboot, I guess it's not, yeah, it's not saved in there. So you'll have to type in Python and the file this code is saved under. As you can see, I have mine saved under robotcard.py, so you'll type in, so for me, I would type in Python robotcard.py, and you would type in whatever your file is named, and then hit enter. The screen will go black, and you're ready to start moving around. So this is the front, this side's the front of Strawberry, that side the wires are coming out, this side's the back. So kind of give her some room. So I guess we'll just kind of turn everything there. So I don't know how this would sound through the mic, but as a warning, she is very loud. Strawberry is very loud, so just as a warning, you might want to turn your volume down a little bit, but I'll try to edit it as best as I can before I upload it. So this is her, so push O, and this is her turning right, and then left, and stop. So like I said before, she'll just keep going in the direction or spin in the direction after the button is pushed. So you'll have to push U, like if you want her to stop, you have to push U right after, so you have to be pretty quick about it. So like you can see, I can keep doing that, and then she'll move forward like that, go backwards. So yep, that's the first form of Strawberry. Insert not even my final form meme here. But anyway, and then to get out of the code, I think it's Control-C. Yep. And then you just put in the keyboard input, Control-C. I'll throw in a try finally thing with the keyboard later so it doesn't crash the code every time when I have to put it in. But as of right now, it's just a really basic version of everything. So hope you enjoyed and learned some things about the Raspberry Pi from this. Check out my Instagram account in the bottom. That's where I've been posting a lot of other things electronics wise, and using the motor controller and linking it to the Pi and all that stuff. Check out my gaming channel. All that stuff will be down in the description. And until next video, see ya!